Hello everyone. In this video, we are going to look how we can display the distance measured by ultrasonic sensor on LCD screen. In earlier videos, we have seen different ways of displaying the distance using LEDs, which won't show the actual distance. It just says relatively how far the object is to the ultrasonic sensor. And we have seen on the single 7 segment display or multiple 7 segment displays, but they will just show numbers, but it won't display the text like distance measured. It just displays the number. So what we are going to do in this project is use the LCD and give little bit of touch of actual text instead of just number saying that this is the distance. Now we will go and look at the connections between Arduino, ultrasonic sensor and LCD. Yeah, I have made the connections in fridging. If you look at, we have majorly 4 or 5 components. The bigger one is Arduino, ultrasonic sensor, LCD display, potentiometer and small resistor. Now let's dive into the connections. HC-SR04 ultrasonic sensor has total 4 pins. One is VCC, another one is ground, and two are trigger and echo. VCC is connected to the 5 volts pin of the Arduino indirectly using the breadboard. The ground is connected to the Arduino, but again indirectly through the breadboard. Now the trigger pin of the ultrasonic sensor is connected to the 13th pin of the Arduino. The echo pin is connected to the 12th pin of the Arduino. Now let's look at the connections with respect to the LCD. As you see here, we have potentiometer also connected, but before going to the potentiometer, let's go one by one. The first pin, that is the VSS, is connected to the ground of the breadboard, and the second pin, that is VDD, is connected to the 5 volts, that is indirectly connected to the 5 volts power supply of the Arduino. The third pin, that is VO, is connected to the output pin of the potentiometer. Potentiometer, the other two ends are connected to ground as well as the 5 volts. Now the fourth one, that is RS, resistor select, is connected to the 0th pin of the Arduino. This indicates what exactly the instructions are, the data, what you want to send to the LCD. The fifth pin, that is read write, is directly connected to the ground. That indicates we always wanted to write to the LCD, but we are not intended to read back anything from LCD. So just to save connection to the Arduino, you can directly connect to the ground. That means the particular R_W pin will be set to 0. The sixth pin is enable pin. That enable pin is also connected to the pin 1 of the Arduino. That indicates to enable the LCD. Now coming to the 4 digital pins, that is D4, D5, D6, D7. These are the pins through which we will send the data or characters or the actual distance measured by the ultrasonic sensor to the LCD. Now these 4 pins are connected to the digital pin 8, 9, 10, 11 of the Arduino respectively. Now we have the anode and cathode of the LCD. Now the anode is connected to the 5 volts through resistor to limit the current. So you can use any 220 ohm resistor or any bigger one. Ensure that you won't fry up your LCD. And the cathode is connected to the ground. Now this sums up the connections. Now let's go to the source code and we will identify how these connections we are mapping into the libraries. We are utilizing two major components. One is the LCD and as well as one is the ultrasonic sensor. We are using the liquid crystal display inbuilt library to control the LCD. So we need to include that particular header file, as well as we are using the HC-SR04 library, include that header file also. Now we are initializing the object or maybe the function. We are initializing the liquid crystal library with the pins what we have connected so far. What it needs is the LCD library need to understand what are the Arduino pins we are connecting to the select pin, enable pin on the data pins. Now if we go back and look at the 0 and 1 pins are select pin and enable pin. So this particular 0th pin of Arduino is connected to here. This is actually register select, and as well as the first pin is connected to here enable. That is what we have coded here, and the data pins of the LCD are connected to 8, 9, 10, 11 pins of the LCD. Now the second code line indicates what are the trigger pins and echo pins we are using from Arduino to initialize the ultrasonic sensor library. That is, if you look at here, we are when the library is beginning in the setup function, we are telling to use trigger pin as 13, echo pin as 12. Now I am telling to the LCD library that I have LCD display, LCD hardware, which is 16 characters per row, total 2 rows. That indicates total 32 characters I can display in the LCD. Now I am printing LCD print distance colon. So this one I want to display I want to write only once, so that the code will become little faster. This why instead of putting in void loop, I am just putting in setup, because this distance colon is not going to change throughout the program. In the loop function, which will be called continuously, I am measuring the distance using the measure distance centimeter function, and the first this distance centimeter returns an array. The first item in the array, that is which is present at the index 0, gives the distance in centimeters. I am telling to the LCD library, now you move the cursor to the 13th character. In 13th character, from 13th character, I want to display the distance in centimeters. Once the distance is printed on the LCD screen, I am waiting half a second. After half a second, I am clearing the distance whatever it is printed. So from 12th character, to be on the safer side, till the 16th character, I am clearing of the data. I am just printing the blank. Why this is needed is, let's assume we are measuring the distance more than 100 centimeters. In the first object is at 100 centimeters. In the LCD display, we will see 100. In the next instance, if the distance is reduced to 90 centimeters, if I don't clear the third character which I have printed earlier in the distance centimeters, I will still see 900. But our actual distance is 90 centimeters. To avoid that confusion, I am clearing of all the characters, so that the distance whatever we are measuring afresh, that will be printed. As you see, the distance actually slowly reducing as I move the object closer to the ultrasonic sensor. As I move the object slowly further from the sensor, the distance is getting increased.